Good afternoon, everyone. Thanks for joining us today. We are going to get started here in just a few minutes. If you are on and you can hear me, can you please just chat in the box so we can make sure? All right, welcome to our webinar, Small Investments, Big Returns, 3 Successful Data Science Use Cases. SenseCorp has been around for over 2 decades, offering a variety of consulting services across data, digital, and business transformation. Our team of skilled consultants offers insights and solutions to the most important problems facing business and government. Today, I have the pleasure of introducing our speakers, Susan Devitt and Shreya Shenoy. Susan is a senior data scientist at SenseCorp, delivering strategic big data and analytic solutions to help clients make data-driven decisions. She has over a decade experience in the full life cycle of data science projects, from data engineering and quality assurance to model deployment, interpretation, and data visualization in a variety of industries, including biotechnology, retail, and oil and gas. Shreya is a data scientist at SenseCorp with a linguistics background. She's experienced in addressing business needs with data-driven solutions and has strong Python, SQL, Spark, and data visualization skills. All right, thank you for attending today's webinar. We're going to go ahead and get started. Susan, the floor is yours.
Great, thanks so much, Kelly. Can you hear me okay?
We can.
Great. So this talk today is part 2 of a lecture or webinar series that was given a couple of months ago about why data science projects fail. And we see this in the real world very frequently. This is a quote that came from Gartner. 80% of the analytics insights don't deliver business outcomes, so they're working on the wrong problems. And 80% of AI projects remain alchemy run by wizards. They're not successfully able to be put into production. And Shreya and I are here to talk about 3 use cases today to hopefully convince you that data scientists are not wizards, and to shed a little light on successful use cases, and in particular some tips about do's and don'ts and some ideas to keep in mind for having really successful projects. So this comes from our data ebook and came from the previous talk that I mentioned that Gabby Leo gave about why data science projects fail. If you haven't watched that, I would encourage you to watch it as a follow-up to this, because they come together really nicely. And today we're going to talk about 3 use cases that really exemplify these do's. On the right-hand side here, the orange, right? We're focused on small projects, being agile. We're going to talk about projects that are in the scale of weeks, not months or years, focusing on small teams and really being able to move fast and deliver solutions. And I boiled this down to 3 main tips or best practices for when you're trying to identify and choose a use case. The first one is really starting simple. So work with existing data, work on a small problem. A lot of times when we're thinking about data science and AI, there's so much potential and there's so much value that's possible to gain that we can often think about really large problems and really sort of get carried away by that kind of ultimate long-term solution. When we're really starting, we really want to be very simple. And a big part of that is prioritizing. So think of all those use cases, think of all the kind of potential uses, think about the different ways across streams in your business that this could be used and be useful, all of those use cases, and then really ruthlessly prioritize them, and really prioritize them based on feasibility, technical feasibility, as well as potential value to be gained. And that one is so important. That's actually my third point here about generating value. So when you are beginning to adopt an AI strategy, maybe you're a data scientist working at a company, trying to move and work on new problems and new use cases, you need to get kind of buy-in within your organization, really focusing on a use case that's going to generate value and be very apparent of what that return on the investment is really critical for these early use cases where you want to generate momentum. You want to have kind of big wins in the beginning so that you can begin to build upon those as you're expanding your AI and data science reach within your organization. And so today I'm going to talk about 3 use cases that I think highlight those principles really nicely. The first one is an inventory categorization that we did for an oil and gas client. The second one is looking at sales forecasting, anomaly detection. So we're obviously living in a big anomaly right now in terms of COVID. We certainly haven't ever lived through COVID, and a lot of data scientists saw kind of when COVID hit, right? A lot of our models broke because we are in an unprecedented time. But with that said, we can learn from perturbations in the past. We can learn from analogous events or other types of events in the past. That information is in our data, and it lets us be able to improve our predictions and start to figure out how we're going to build that rebound and recovery. And then the last use case that Shreya is going to present today is focused around computer vision for public safety and using computer vision automated image detection to improve public safety. So the first one here, just to highlight, this is a short-term project, 1 data scientist involved. And this is a project where the data scientist really saw the need and implemented a solution or began to explore the solution. It kind of didn't come down to them, which I think is often really powerful if data scientists and data science teams are really empowered to be able to look at the business and they have enough knowledge of the processes to be able to start to see, wow, where can machine learning and automation, where can it really be applied and be really successful? And this is, I think, is a great example of that. So the problem here is that there are many, many parts and products. In this case, 266,000 items, each with a SKU. They need to be organized into categories. And that's important because there's a lot of downstream applications that depend on this data and really need to be accurate so that it can be used in cost analysis and reporting. So it can be used in optimization or savings. So it can be used in other AI applications like predictive maintenance. And previously, this was a very tedious process. It was a very manual process that took forever and needed a subject matter expert to be able to do this categorization correctly. But there were still manual errors, and it was a very costly process. And it was something that kind of always needed to be updated because parts were changing from the manufacturer, competitors were being acquired and kind of bringing in, their data system and their categorization system. So this was sort of a job that was never ending, but was quite tedious. And so it's possible to use machine learning and natural language processing, which is essentially using a computer to read and understand language so that it can do categorization and matching. And that's exactly what this project did and achieved. And so here I'm showing results. There were 9 models that were tested, 9 machine learning models. And what I want you to see here, there's sort of a couple things to kind of take away from this graph. So the first one is that we looked at a bunch of models. Most of them did pretty well or very well. And one of the things to keep in mind here is that we really only need one model. But when you're putting something into production as a machine learning or data scientist, we always are looking at multiple models and trying to optimize and choose the best one. But when we go into production, we really want to always put more than one model and more than one type of model into production. And this is really key because if our results start to change and look strange, it's not clear whether this is a model issue, something like model drift or bias that's coming into our model's not working properly, or whether it's the data and there's some sort of issue with the data. And the only way we're going to be able to distinguish those two, or be able to distinguish them very quickly, is to have multiple models. And we know, okay, is one model, is our decision tree starting to fail, in which case maybe there's model drift going on there. And we can retrain our model, or are all of our models starting to give suboptimal results, in which case maybe something is going on with our data. Maybe there's a new process or something else that's going on with the data. So that's a really key tip. The second thing that I think is a really important general best practice is thinking about the idea of the 80-20 rule. So the idea that you can kind of get 80% of the results with 20% of the effort. Sometimes I've seen that described as like the 10-90 rule, or even the 5-95. But the idea is that, you know, your good enough model is going to capture most of the data, but maybe not all. And those edge cases that kind of last, in this case, last, 2% of categories, those very rare, very infrequent labels, those are actually really hard to categorize. And a model is not going to be able to do that as well as an expert. And we don't want to spend all of the time trying to get that sort of optimal solution that gets everything. We're going to go for good enough here, right? This is something that was completely manual, and now we're able to take, on my next slide here, 98% of the data and classify it with over 90% accuracy. And that's a huge gain in terms of the effort. And another kind of best practice, or just sort of tip here, is that really the finer you can make those categories, the more labels that you can have, the more learning your model can do, and the better accuracy it's going to get. But again, I want to just really emphasize that point of don't really stop at the good enough solution. Implement it, do it in a controlled way so that you can test your effectiveness, and then move on from there and kind of improve from there. But I think this is a real, data science as a field with these use cases, that saying don't let the perfect be the enemy of the good, right? We really want to just get a model that's good enough, that's going to improve, and then we can make improvements after it's been put into production. So to summarize this first use case, we really were able to reduce cost, and the cost here is really in terms of our subject matter experts and employees. This was not their core work that they needed to do, that they wanted to be doing. This was very tedious, time-consuming work. And so now these resources are freed up to be able to kind of do their main function and not have to spend nearly as much time on this. And it was a 90% reduction, both in terms of the time as well as the manpower. So something that was previously a 2-week process now takes less than 1 day. And again, I mentioned, this isn't something that just has to be done once. This is something that continually needs to be updated as new parts come in, as competitors are acquired, as new types of machinery and parts are acquired. And now that this model is in production, it's just going to keep classifying and updating that information. And that ultimately this really leads to an increase in accuracy. So now that we have this data that's easier to get, that we can get faster, it's more accurate, and we can now use it in all sorts of downstream applications in terms of automation, optimization, smart assistants. And this is, I think, a great example of being able to sort of build on successful data science and momentum. This actually, for this particular client, after this optimization project was done, then they were able to really sort of see a path forward for some optimization and kind of smart assistant work that they could do to make their employees' lives easier. So the next use case that I'm going to talk about is a parts supplier, and this is looking at forecasting and market segmentation. So this was a 2-week proof of concept. Again, one full-time data scientist involved in this work. And this project was a much kind of larger, kind of years-long effort for clean data, master data management, really getting, again, similar to the previous example, getting all of those categories straight and SKUs, you know, one SKU per one product, getting all that together. We then had a really amazing data set to be able to start looking at what's really going on. And one of the challenges with big data that we all realize is the data is so big and so complex. Here we're looking at 7 million daily transactions. You can't just look at the data and uncover what the pattern is. You can't really just look at the data and know kind of what the trend is, what the noise is, and therefore it makes it very difficult to forecast. And in this particular client, they were quite reactive in terms of their planning, where they could really just sort of look at kind of what happened in the last quarter and try to predict where they were going to go in the next quarter, just reacting on what had happened in the past. And the goal with this project was really to try to flip that, to try to say, okay, we can look at that data, we can look at a long-term historical record for your sales, and we can begin to start making predictions and using that data to inform our forecasts. And so when we look at this data, you know, we've got those daily records. Even if we look at kind of weekly or monthly averages, it's still not clear. There's a lot of noise in the data. And again, this is for 450 locations throughout the United States. And time series analysis, actually breaking this information apart into what is really the trend, what is the seasonal pattern, what are the anomalies and residuals, lets us begin to understand what's happening so we can make those predictions. And so this project had 3, again, this was within this 2-week period, but we had 3 sort of goals we were looking at. So using time series analysis to really decompose and try to identify what is the true trend, what is the seasonality. And again, we could do this for all of the data. We could do this for territories, for individual stores, for individual parts, whatever the question is that we're interested in. And then once we do that, what we're really interested in is how can we start to group things together in groups that make sense? And I always like to use the apples and oranges analogy. So I want to get all the Apple stores together so I can build an Apple model so I can predict those. And I don't want to have any stores that are oranges in there, because I want to group those together and make a model for those stores, because they might actually be doing very different things. You can think about parts of the country that are expanding, and so you know, the business might be expanding there. Other parts where we might see sort of steady state or even some contraction. And in our machine learning models, we really want to have those separate so that we can build really accurate models and understand what's going on. And that brings us into the last bucket here, optimization and forecasting. So we want to identify leading indicators of our trend and of our growth and our patterns, so we can start to build predictions. And this becomes really important, again, when we're thinking about any sort of anomaly or perturbation, and thinking about how we might rebound and recover out of that anomaly. So this is what a time series decomposition looks like. This line on the very top here that's observed, that's just one of those lines I presented in that previous graph. And we can actually break that apart into 3 separate components. And we can break it apart. We can also put it back together. And so the first piece that we want to pull out and look at is, what is the overall trend, right? Are our sales increasing? Are they decreasing? Are they the same or different across stores or across regions? That's the trend. And again, I would sort of challenge you, if you looked just at that line on the top, it might not be readily apparent, right, that you had this sort of peak in 2018 and then kind of a decline back to the 2017 levels in mid 2019. But when we do this decomposition, we can see that pattern really clearly. The other thing that's very important to think about is this seasonal pattern. So most industries, most types of data have very regular patterns that we call seasonal, but you might even think about something like electricity use, right? It has a very clear daily pattern. Or maybe in retail sales, you have a very clear weekly pattern where you have kind of higher sales on the weekend when folks are out shopping, lower during the weekdays. Those regular patterns are really important to understand and to account for in your models, so that your models are more accurate and are more representative of the truth and what's actually going on. And then the last line here, the one on the very bottom, the residual, that's everything that's not explained by the seasonal pattern and by the trend. And so this sometimes we can think about as kind of the noise in our data. And in some cases, it might actually be noise, but it might also actually contain really important signal. So I would be really curious to see what's going on here in the fall of 2018, where I have this kind of highest peak there. I would be really curious to know what that was. We were also really curious to know what was going on at this lowest trough here. So the sales here, again, were for this particular store, were off by $20,000 from what we would expect during that week. So what caused that? Well, it actually was caused by a major hurricane. So when we go back and actually look in the data, and these factors that we're looking at, they could be both external, like here, like a natural disaster, but they could also be internal factors. So maybe you implemented a new policy, maybe you started a new marketing strategy, maybe legislation changed that affects your industry. We can look at these both kind of having an a priori or before the fact idea of, I really want to understand that policy that I implemented in January of 2019, what effect it's having. So we can look at the data and really clearly see that. Or we might also be able to go back and look retroactively and think about, okay, I see this big anomaly. What was going on in my business or in the world at that time? And once we do that, once we identify that anomaly and that residual, what we really want to understand and where models can really help us is help us understand the path out of that anomaly, right? So we knew that sales were going to be off because of this hurricane, but what we really want to understand is then how do we recover and move back to our kind of regular trajectory, and how do we even know once we've achieved a recovery and we're back on our trajectory? We have to look at the data to be able to tell us that. And in particular, this S-shaped or sigmoid curve has a couple of pieces that are really important for forecasting and predicting. So the first is the bottom part of this S, this kind of flat, if we think about this as a letter S, this kind of flat part at the bottom, because this tells us how much of a lag is going to be present before we start to recover. And this was particularly important for this client because shipping and freight costs are a big part of their costs and their bottom line. And so if they can have at least a 2-week lead time, they can ship via rail, via train, and save it's sort of twice it's twice as expensive if they have to ship by truck. And so if they can get that 2-week lead time and know when they're going to need the product 2 weeks in advance, they can send it there on rail and essentially double their profits or half their shipping costs. And the other thing that's really important here is this sort of slope and this kind of rate of increase. So again, significant transportation costs. This is also an industry that they can't keep product around for too long, or it begins to get stale. So they can't get it there too early. If they get it there too late or kind of just in time, they're going to pay those higher shipping costs. So being able to predict the rate of the slope is really important. And again, we have this information for every store, for every region, for every hurricane that's happened in the last 2 years. And we began to look at sort of what's the average lag, what's the average slope and rate of increase, so that when a hurricane hits, just like we're having right now, unfortunately, in the Gulf Coast, we can tell them and give them insight. Okay, it's going to be 2 months, but in 2 months, that's when your demand is going to start and begin to pick up. So the last piece of this use case was looking at and identifying leading indicators, both at the macro scale as well as the local economic scale. So we looked at a variety of kind of large scale economic factors. Here on the orange line here, this is the 30-year mortgage interest rate. And what we see is actually a very high correlation, a 0.62 correlation between that trend and the 30-year mortgage rates. So that's a really good indicator for this business. And maybe they had that intuition. They knew that their business is kind of tied to economic growth and interest rates. But here it really shows that, and we can see that it really is borne out in the data. But the key thing here is it's not a one-to-one correlation. So they actually have the highest correlation at a 50-week lag, which is almost an entire year lag. And this is a really amazing and powerful tool for making predictions, because we have this leading indicator. We know that as these interest rates change, we've got about a year to be able to then feel the effect in our business, and can make decisions. Both it can improve our forecast, but we also might make other sorts of business decisions about resourcing or hiring, acquiring, product purchasing, based on this really important leading indicator. But what we also saw when we really dove into the data at the local level, when we did that clustering analysis that I mentioned, getting the apples and oranges together, what we found was that the Houston metro area, the stores within that area, they did not cluster with any of this other stores in the Texas or kind of Gulf Coast region. They're really doing their own thing. And we started to wonder, well, what's going on there? And what we found was that market, the Houston market, is really, really tightly driven by oil prices. So, jobs, industry within Houston, that local economy is very tied to oil and gas industry. And so as we see falling oil prices or rising oil prices, the Houston economy, and therefore sales for our company within that metro area, respond. And they actually respond right away, so with no lag, with a very, very high correlation. So I mentioned that the 0.62 correlation is really high in terms of real world data. A 0.76 correlation is extremely high in terms of being able to actually see it in the real world with everything else that's going on. And again, this is really powerful for our company and for folks involved in decision making in that region to know, right? Because we might have implemented some sort of strategy or some sort of campaign in that region. If it is not getting traction, it's not because it's not working, it's because the oil prices have fallen, right? And so it's really important to understand those drivers at both the local and the large scales. So to summarize this anomaly detection and forecasting, we use time series analysis, and it was let us uncover these non-obvious trends where we could kind of deconstruct the data, look at what was trend, look at what was seasonal pattern, and then put them back together to begin to make predictions. And we saw, looking at those residuals, that anomalous events or perturbations, we could look at those to begin to build forecasts to reduce uncertainty. And again, in this case, we were really interested in that kind of timing, so we knew when to get product where we needed to get it. And those time lags and those macro and microeconomic drivers are really important to improve our accuracy of forecasting. And the drivers I talked about today were both external to our company, the oil prices and mortgage interest rates, but those could also be internal factors as well that we can look at and see how well does this actually explain the data. Often decisions are made based on intuition. We have an idea about what might be driving our patterns, but this type of analysis lets us really test that. And if we're correct, great. Can kind of go on and do it in a much more quantitative way. Or if not, then maybe we can identify the underlying factors so we can really improve the accuracy of our forecasting. And so now I'm going to turn it over to Shreya, and she is going to talk about a project that she worked on around computer vision for public safety.
Yeah, thanks, Susan. Can you guys hear me fine? I'm going to take that as a yes, and we'll get started. Computer vision is an incredibly interesting field, one that's being used every day with applications ranging from things like mail sorting to medical imaging to self-driving cars. There's a lot happening out there. Now, despite being a fast-moving field with growing applications, computer vision itself is still very much a non-trivial problem. So what do you need to do computer vision? It can get pretty intensive in terms of resources, and there are a number of trade-offs involved with the implementation, depending on what you want to end up doing. What you choose to do and how you approach it are going to depend on your priorities. So say if you want to prioritize accuracy, you want a model that is almost always going to tell you what it's looking at or identify the object that you need it to. You could do that perhaps by leveraging an existing model framework or by building your own custom solution from scratch from the beginning of the convolutional neural nets. Depending on the model and your setup for running it, however, that might slow down your performance significantly. For example, if you're trying to run it locally on your laptop or something, and if very quick delivery of those computer vision results is not a priority, maybe that's fine. Maybe it's okay for you if that model takes 30 seconds to run every time you need to run it. But if you do need faster results, maybe you'll choose to leverage cloud computing. Maybe you'll even use a cloud service with pre-trained models instead of building your own. Some limitations there would be related to what those models have been trained to do. If you have an extremely specific visual target that you're going to need to be working with, you may not have the most accurate results because those pre-trained models haven't been customized to your data and your problem. There are a lot of options involved with implementing computer vision when you want to actually apply it to your use case. And so for this use case, public safety, this was about school safety, specifically aimed at responding to school shootings. Now, unfortunately, in this country, school shootings do happen, and they happen more frequently than anyone would like. Having an early warning system in place would be invaluable for helping first responders arrive at the scene more quickly, while also having more information about the incident or the potential gunman. One of the stakeholders involved in this project was ex-law enforcement, and he stressed the positive impact that a system like this could have, where first responders would be able to have more actual concrete information about who they should be looking for when they show up at the scene, perhaps with an image of the alleged gunman, as opposed to having to rely only on information from 911 calls, which can sometimes be confusing or have conflicting reports. For this project, the goal of this proof of concept was to detect from a security camera whether an individual in the image was armed. If we did detect an armed individual, send a notification immediately and have an end-to-end runtime of 3 to 5 seconds. So that's 3 to 5 seconds from ingesting the image to doing all of the computer vision on it, to getting the notification sent and the relevant personnel notified. This image is one of our test subjects holding one of the multiple firearms we tested with. Now, for implementing computer vision for this use case, what choices did we have to make? We could have built from scratch or off of one of the popular existing computer vision model architectures out there. But when we were exploring at the beginning of this project and we did some initial testing, it showed us that, for example, using a model called ResNet, it took over half a minute to run. I believe it was 48 seconds. And we could not wait 48 seconds to get results every time we passed an image in. We needed near real-time results, because we were going to be streaming images into this algorithm constantly, and we could not have a lag of nearly a minute to find out if a minute ago did we detect someone with a firearm. On top of that, we were coming into this project with no data on hand. So we didn't have a lot of security footage or images of people with guns, none of that coming in. We didn't have a whole lot of infrastructure existing to support some of the work like this, like GPU setup to train and run our model locally. And we were also using existing cameras we had to simulate that security camera. Since this was a proof of concept and scalability was not one of our main concerns with at this time, our top priorities were really accuracy and that runtime and speed. So we decided on using an existing pre-trained model with an off-the-shelf API due to its accuracy, quick speed, and ease of implementation. And since in this case, we weren't trying to detect something very, very specific, such as identifying the type of firearm, this approach worked for us. As you can see in this image here, we're identifying a number of things about the photo itself, the house, the windows, the door. We're identifying the person, and we're identifying that he's holding a firearm, or here the label says rifle. We didn't really need to be able to identify at a more granular level what kind of firearm this person is using. So that pre-trained model approach helped us. It let us achieve computer vision results in around 2 seconds. That's that near real-time results. That's what we wanted, with high accuracy on top of that. And this is an image taken from a day of live testing to serve as an example for how our model works. In this case, with an image containing multiple people. So we did a few rounds of live testing. We had a number of test subjects who walked around this elementary school parking lot holding a variety of different items. So we had a couple of test subjects with the firearms. We also had people walking around with, in this image you can see, there's an umbrella, I think that's a golf club, there's a baseball bat, all sorts of things that you would expect students attending this elementary school to walk around holding. Because again, we wanted to make sure we could successfully identify both when someone did have a gun and when someone did not have a gun. In this case, with multiple people in an image, what our algorithm does is it finds each individual and cycles through them, trying to detect a firearm. Now, the first person that it found was probably one of the two men in the foreground standing on the sidewalk, because all we detected from their person was asphalt. So all we noticed of interest in the area of their body and surrounding their body was the sidewalk. The next person it found was the gunman. As you can see, when it looked at him, it detected that firearm immediately, and we got very relevant labels coming back from it. This triggered that notification immediately without waiting to check on others in that image, which is what we wanted it to do. And as for our overall performance and results with this, we achieved our goals for the speed with an end-to-end runtime of 3 to 4 seconds. And that's 3 to 4 seconds at the longest when a firearm was actually detected, with the notification being sent and received. We had an 88% accuracy at detecting the guns with the current algorithm as well. And we definitely have some room for improvement with next steps. This, what we put together in this project, this is by no means a perfect solution, but it's still providing value. And I think that's the key thing. What we built isn't, it's not gonna find a gun if someone has a gun in their pocket or hidden behind a coat or something, but for the eventualities where a gunman is just holding the weapon out in the open in front of him, a system like this, like our system, could work with that and could make a real impact. Other things we observed that we could improve are, again, related to the accuracy. For example, we saw a couple of false positives when we had one of our test subjects hold a closed black umbrella across his body as if it were a gun and as if he were shooting it. These are other things that we could work on when we move on to next steps, when we build a better model in the future. But again, for this project, this proof of concept, we started simple. We focused on the defined problem that we had, and we aimed for good enough. I think we did pretty great considering. And really, the main points to take away from this use case are really the potential time and resource savings involved with the initial implementation, depending on your priorities and how you approach that problem. You don't need someone with a PhD and 5 years of experience to work on this in order to begin seeing some kind of return on your investment. This kind of thing can also be easily adapted to other use cases. So this one was public safety, specifically detecting firearms, but computer vision is very versatile depending on what you need it to do. You could use it for inventory management, for dealing with shipments. You could use it for perhaps something like monitoring COVID-19 social distancing protocols in public now, considering the times we're living in. The number one thing that I want you to take away from this is you don't have to do it all at once. You can deliver business value quickly if you have a focused problem, even if you're trying to implement computer vision.
Great, thanks so much, Shreya. So to summarize, today we presented 3 use cases across a variety of industries using a variety of machine learning and data science tools. And I think hopefully we're able to illustrate some general principles where we were able to start simple, we were able to prioritize and focus our use case and deliver value. So in the inventory categorization, we were able to achieve a 90% reduction in the effort required in this ongoing task. When we looked at sales forecasting and time series analysis, we were both able to detect anomalies and also look at both large and small scale drivers, and in particular, identify some leading indicators that will be very powerful going forward when developing projections and forecasts into the future. And then Shreya just showed us a very complex technical solution that they were able to achieve in a short amount of time by using some existing tools, by really focusing on what their prioritization and what their value that they needed, that runtime, and were able to achieve accuracy that was adequate and appropriate for the solution that they needed. And so I just want to kind of, we've talked about these 3 specific solutions in 3 specific industries. But as we all know, AI and data science, automation is being used in all sectors, in all industries, both across private businesses as well as within the public sector. And we've identified, I think, 3 data science techniques. So that kind of categorization, time series analysis, and computer vision that could be applied to virtually any industry where these types of cases exist, where we have time series data or where we have items that need to be categorized, or in Shreya's case, images that we want to categorize or detect. And that this AI, if we can do it successfully, and again, going back to that initial quote, we all want to be part of that 20% that's able to do AI and automation successfully, because if you're able to do this, it's not easy, but if you can do it, you're going to have the competitive edge and the competitive advantage. You're going to be able to move way beyond your competitors that are stuck with those data science projects that they just can't get off of the ground. And to do that, to reiterate, start simple. Use the data that you have. Don't get caught up in the idea that you need more data. The best data that you have is the data that you already have in hand. And really ruthlessly prioritize. Focus on those use cases. It's certainly a very useful exercise to think about kind of all the possible AI use cases and to do a lot of visioning and to really think really big picture. But when you get ready to actually choose your use case where you're going to start, really focus on those that use case that you can define very well and that has high feasibility and high return. Because the ultimate goal for being able to build momentum, to get buy-in, to be successful is to really focus on those early use cases that you can implement that are going to very clearly generate value so that you can build on those. And then be able to take, build on those successes as you then expand your data science and AI journey. And to summarize, I think I already alluded to our ebook, but we have a great ebook that contains some of these principles as well as many other ideas called Reaching the AI Summit that's available for download. And with that, I'm going to turn it over to Kelly to see if we have any questions.
Thank you so much, Susan and Shreya. That content was very interesting. Reminder that if you have any questions, go ahead and type them in the Q&A box. We do have a few that we're going to start with, but feel free to just keep typing them in as we go along here. So first, Susan, how do you prioritize use cases and where does the tool or technology selection come into the process?
Sure. So I think that that's part of that middle piece, that prioritization. So I think that you definitely limit yourself if you sort of just kind of start with one thing. So I think there is a lot of value of kind of capturing all of the kind of potential use cases or places where we could use AI and data science. But then when you get ready to actually prioritize and kind of just depending on the scale of this project, this might just be something that a data scientist does, right? They could think of 5 potential use cases and they could prioritize them for themselves. But ideally, you also have the business owners, the folks that really understand the process and kind of the ultimate value and kind of challenges to be able to help advise so that you can really put, you can really quantify what is that potential value and how feasible is it? And then you want to look at those ones that, that hit both of those, right? High feasibility and high value. And that's what you're going to choose. It doesn't mean that the ones that are high value, but maybe be more of a challenge, you're not going to ignore them forever, but that's not where you're going to want to start. And then the tool question is a good one because I think sometimes, you could spend a full-time effort just thinking about, the right tool and, doing a lot of exploration about the technology landscape and what kind of investments you want to make there. I know the ebook talks a lot about that, but that's really something to think about kind of later in the journey. And I think Shreya's use case highlighted that really nicely. So they did, a fairly rapid assessment of the technology landscape, and they chose to use kind of an off-the-shelf API, used commercially available cameras, and they were able to work within that 4-week timeframe. Shreya alluded to that as they expand and continue this work and start to think about cost and start to think about scalability, they will have a more nuanced discussion around tools. But again, this was a good enough tool for the job, and it let them achieve that. And so I think, going back to that, saying, it's like the best tool you have is the tool for the job is the one that you have. So, if your data scientist works in R, then R is going to be your best tool. If they work in Python, then Python, and kind of use what you have, particularly for these early use cases.
Okay, thank you for that answer, Susan. Another one here. Many of these use cases were accomplished with one data scientist. Should I just start with one? What are the other roles that I need?
Oh, that's a fantastic question. We think a lot about this in terms of how to build a really effective team. And I don't want to make it seem like you only need one data scientist. What we would recommend is thinking about both what resources do you kind of already have in your organization that you might be able to provide some more training and upskilling for a data team, as well as then what sort of resources do you need to hire. We do recommend when starting a team, these smaller sorts of teams that have 4 to 6 members that tend to be able to move very quickly can be a really very effective. And besides a data scientist, thinking about having, if you have 4 to 6 folks, thinking about a chief data scientist, the person who really owns the strategy and communicates it, having a business owner that may either be kind of directly with the data science team or works with them very closely so that the data science team has a really great understanding of the business application. And then also thinking about data engineers. So we didn't really touch on the kind of data engineering and data acquisition process, but that's a really key and critical component of this type of work, is being able to have that data, and particularly when we're thinking about pipelines, having architects and data engineers is quite important as well. I would say, I guess, just to kind of on the flip side of that, if you do have maybe only one data scientist already, or only kind of, have one, want to hire one data scientist, I think being really realistic and very protective of the data scientist time so that they are focused on data data science, often a data scientist, if they're the only person in their organization, they get sort of stuck on a lot of other things, data, visualization, ETL, data cleaning, and they're not able to prioritize that actual data science. That would be my one caution for that.
Yeah, that makes sense. Shreya, I think this question's for you. I'm curious about how you plan to address the limitations of your current solution. For example, I noticed that all of the individuals involved in testing are white men. Do you think this would affect the real world performance of your model?
Yeah, that's one thing that if we were to deploy this model, that would absolutely have an effect on it, just because if it was a model that we were training, we would want to train with as much data as possible. And in this case, since we're talking about people, there are a lot of different kinds of people out there. People will look different, people will dress differently, depending on, say, the weather or the season. There's a lot of nuance to that and the different kinds of things that we would need to capture in next steps if we were trying to, like when we were trying to make this, when we try to make this model more robust. For future steps and a broader application, we would absolutely work on building a custom model and trying to cover all of the possible use cases or possible edge cases that we would have. And ideally, we would be training with images from a variety of different people. But for this particular use case, I will emphasize again, this was a first step that we took. So there are inherently going to be some limitations surrounding that. As long as we're aware of those and we know that given more time, given more resources and broader scope, as long as I think as long as we're aware of the next steps and the caveats of proceeding the way we have, it's perfectly acceptable to deliver this as in this case, it was a proof of concept.
Okay, thank you. We do have just a few more minutes here. I want to squeeze in one more question. Okay, how do you get buy-in and agreement on a specific use case?
Okay, so this, I'm wondering if this maybe, it could either come from the data scientists, right? So that first example that we had here, this was sort of a solution that was proposed kind of by the data scientists. It didn't kind of come to them. But you could also maybe have just sort of disagreement around the prioritization. So I think that, those two criteria that I mentioned, that kind of feasibility and value, I think that those are really going to be the criteria that you want to use to try to get buy-in, and in particular thinking about the return on your investment. So where are you going to have the largest potential impact, and using that as your criteria for prioritizing. And again, I want to keep in mind that this is for an initial use case, and that there are many other potential use cases. I also think that idea of starting small. So if you maybe just have resistance to changing the process, and maybe skepticism about whether data science and AI and automation can improve your process, really starting small. So having a very defined use case where you're maybe just looking at a single segment of your market, or maybe you're implementing a strategy just at a particular store for one particular process, and you can do that in a way where you're collecting data about how your strategy is doing. By starting small, if it's working and giving that return on investment, then you really are demonstrating the value, and that resistance should hopefully be addressed and alleviated if you're able to demonstrate that.
All right. Well, thank you, Susan and Shreya, for your time and for sharing your expertise. To the audience, thank you for participating. and attending today. You will be receiving a follow-up email with the webinar recording and links to future webinars, and we will send a link to that AI ebook that we discussed. If you're watching this webinar as a recording, feel free to email us your questions to marketing@sensecorp.com. Again, thanks for joining us, and we hope you enjoy the rest of your day.
Thanks, everyone.
Yeah, thanks for your time.